morning class, we're going to go over 3.4 polygon angle sum theorem. So we're going to go ahead and look at polygons, continue looking at them. So first of all that we're going to go through, polygon is just a multi-sided figure. It has to be close. So this would not be a polygon because not all the sides are touching. This would be a polygon, everything's touching. This would not be a polygon because we have sides that intersect. So figure all the sides touch, but we don't have any crossing as we go through. So we're going to name a polygon just like we did a triangle or an angle. We're going to name it by all its vertices. So our vertex point, remember, is where two lines meet. So point A, B, C, D, and E. We name it by all the vertices that are involved. Name the polygons pictured. So we have two polygons. We have L and N. That would be one polygon. And then we have P, L, N, and O. Now you can switch the order, but usually we again start at 1 and work all the way around. Okay? You could call, and then you could also go to the big one. M, N, O, P, and L. So you have 3 that are there. So just start at one vertex, work your way around. So here is how we classify it. So a 3-sided figure is a triangle, 4-sided figure is a quadrilateral, 5-sided figure pentagon, 6-sided figure is a hexagon, heptagon is 7-sided, octagon, nonagon, decagon, dodecagon. Anything bigger than that we'd say n-gons, or a 13-sided figure. All right, 13-gon, I mean just 13 sides, 14. As you look at these, we're going to work regularly with a pentagon and a hexagon, octagon. We'll see a little bit decagon or dodecagon, but those are the ones you need to have written out. These ones you need to have written out so you can reference them over and over again, what type of figure it is, because they'll say pentagon. And now you got to go, okay, what's penta mean? Oh, that's a 5-sided figure. And you go from there. Convex versus concave. So a convex polygon, all the vertices are pointing out, away from. So if I looked at it from the center of our figure, it points away. This is away from it. If you look at this, as these lines meet, they're pointing in to the center of our figure. So concave point, or convex, point out, concave, pointing in. So we classify this by its sides and identify as convex or concave. So if I look at it, this is a 1, 2, 3, 4, 5-sided figure. 3, 4, 5, excuse me, 6-sided. 1, 2, 3, 4, 5, 6-sided figure. They all point out, so that'd be convex. So we'd say a hexagon, convex hexagon, okay, or hexagon that's convex, either way. Hexagon that's convex. Here, this is definitely concave. We have these pointing in. Then we count 1, 2, 3, 4, 5, 6, 7, 8-sided figure. So it'd be an octagon, and that'd be concave. Now we're going to look at this. So we look at triangles. Think about triangles. We know that triangles have 180 degrees. So if we look at for example, a quadrilateral, or we'd say this is a rectangle, but there's one triangle here, one triangle here. So how many total degrees in it? Well, if there's 2 triangles, it'd be 4 sides, gives us 2 triangles, which gives us a total degree of 360. If we look at this, how many sides is this? 1, 2, 3, 4, 5. 5-sided figure gives us 3 triangles. So that would give us a total of 540 degrees, or 380, 180 times 3. So we're going to use this process if we think about it. So if we went to hexagon, how many triangles would there be? So how many degrees would we have? So if you continued on, we went where I did this. 3-sided, we did this. 2 sides, we did this one. 5 sides, so hexagon, if we went 6-sided, we'd have 4 triangles, which is 720 degrees. So what if you look at 180 to 360 to 540 to 720? If you look at it, is there any pattern that emerges? If you look at it, the pattern that we're going to work with is n minus 2, number of sides minus 2 times 180. So if you think about it, we have 3 sides minus 2 gives us 1. 1 times 180 is 180. N minus 2 is 2. 2 times 180 is 360. Because number of sides minus 2 gives us how many triangles we have. We multiply the number of triangles by 180. So here is our theorem that we're going to use. The sum, the total measures of the angle in a triangle is equal to the number of sides minus 2 times 180. So we use that for something like this. We want to find the measure of angle y, this angle right here. We look at, we have 1, 2, 3, 4, a 5-sided figure, which is a pentagon. So we go the number of sides, 5 minus 2 times 180. 5 minus 2 times 180 is 540. So we know there's 540 degrees. Well, we know this angle measurement, we know this angle measurement, we know this one and this one. So we add those all up plus our angle y, and that should equal 540 degrees. Then we would subtract that all, add them all together, subtract, and so angle y would be 135 degrees. That's what we're going to be looking at. That's what we're going to be trying to solve. All right, a pentagon. How many sides is a pentagon? Same thing as a 5-sided figure. Has 5 congruent angles. Find the measure of each angle. So if they're all the same, if I have a pentagon that's all equal, how many total degrees should we have? Again, 5 minus 2 times 180 gives us 540 degrees. These angles should all be equal. So I take 540 divided by 5, which would give us 108. So each angle would be 108 degrees. Next, we're going to look at exterior angle. So interior angle, we did the n minus 2 times 180. Exterior, outside. So if I have, for this figure, this polygon right here, this triangle, I have 80, 130, 150. Right? If I added those all up, what would I get? 360 degrees. Figure 2. I have an exterior angle of 115, of 71, of 75, of 99. What would I get if I added those all together? 360. Took figure 3. Add them all together. This one and this one, this one, this one. What do you think we'd get? 360. So what do you think our property is going to be for all the exterior angles? The sum of all the exterior angles is 360 degrees. So that's our last property for today. So if I go a couple things, vocabulary words. Equilateral means all the sides are equal. Equal angular means all the angles are equal. A regular polygon. Highlight this. You're going to see this. You'll see those as well. You'll see this. Regular polygon means all the sides are equal, all the angles are equal as well. All right? So if it's regular, everything is equal. All angles, interior, exterior, all sides. Okay? So that's our lesson for today. And then we'll go from there.